Hello students, welcome to Hari Chemistry. Myself Dr.Hari Prasad. So today's session students we will discuss the possible number of geometrical and optical isomers in a given coordination compounds. Right. Before lecture already I covered three geometrical and optical isomers of different MA₂B₂C₂, MA₃BCD student. Just you can go through the video and find out the possible number of geometrical isomer. Right. First time if you are watching my video students, so please subscribe my channel and please press the like button student. Your likes are very important to us. Right. So more number of likes that will reach to the reach to the more audience. Right. So please kindly I'm requesting, so please like my video. Okay, right. If content is good, so please subscribe my video. Right. Now look at student. So this is MA₂BCDE. Right. Now in this student, here first I will write combinations. You can take student A to A trans. Now if A to A trans student, the remaining I will arrange in cis position. Now look at student. This BCDE. Already we know very well student, if any four different ligands are in a square, so the possible number of geometrical isomers are 3 student. This is one, and two more representations I will write student. Just observe. I will keep A to A as it is only. Right. The remaining possibility student I will keep BC as it is. Just here I am doing the interchanging of these two. And one more combination I will write student. This is A to A. And the other combination student I will write BD and CE is the combination student. So these are the possible combination if the different ligands are present in a plane. Okay, right. Now you can write the combination student. Here I am writing the combination. So you will get a perfect idea. A to A, B to E and CD is one combination. And this combination student A to A and BD and CE, this is one combination. And one more combination A to A and BE and CD, this is another combination. Here student you can take any kind of metal like chromium, you can take cobalt, you can take nickel, you can take. Right. So there is no issue with the metal student, just we are arranging the metal surrounded by ligands in a different configurations only. Right. So metal is, there is no effect of this coordination, there is no effect of the number of geometrical and optical isomers student. Right. Don't worry about the metal atom and don't worry about the oxidation state also. Right. Okay. Now this is one segment type. Right. Now the possible number of geometrical isomers student, 3 possible isomers. Okay. Now right. Now look at student. Same ligands are opposite to each other. Simply I can say it is a trans to each other. So usually plane of symmetry is present student. Pos is present. Right. So that's why it is optically inactive. Pos is present student. So optically inactive. Right. So these all are optically inactive. Now look at student. The remaining possibilities I will write. So please observe student. Right. Now the remaining possibilities student, I will arrange these ligands b₂c and one more ligand, one more arrangement I can write student. So simply student, so you can arrange b₂c, then b₂d and b₂e. Similarly you can arrange student c₂d and c₂e and c₂e. Right. So c₂d, c₂e and d₂e you can arrange. Right. Okay. Now look at student, here I am arranging one by one student. So this is b₂d and one more arrangement student, you can check it student. So this is b₂e and this arrangement is b₂e. Right. Now if I am arranging all these student, the remaining ligand you can arrange as it is. So this is A to A and remaining will be DE. Right. Now B to D is trans to each other, then AA and you can arrange student CE. So then you can arrange student AA and CD. Right. Now this is B2C orientation. Now I will write the combination student. Combinations here, this will be A2E BC and AD one combination student. One more combination student, BD, AC, AE. This is one combination. One more combination student, BE, AD and AC. So these are the combination I mentioned student, B2C, B2D and B2E, right? The remaining three combinations we will write student, just observe student, write up. Now the remaining combination here I will write student, that is C2D, and one more combination student, this will be C2E, and one more combination, the last combination student, that is D2E. That last combination student, D2E. Now if it is C2D student, I can arrange the ligands AA and BA. Okay na? Right now AA, and this is I can arrange student AA, I can arrange D, or you can arrange BD. Okay. Now this is AA student, AA, and you can arrange BC. Right. Now this combination you can write student. So this combination I am writing, this will be AC, AB and CD. This is one combination. And another combination student, CE, AD and AB. Right. Next combination student you can take, this is DE, AC and AB. Right. Now, so most of the cases student will have doubt also. Sir, why we are not writing this combination? Can we also write, sir, this combination A2B, A2C, A2D, A2E? Yes student, you can write, but you can cross verify. Any similar approaches are there, you can find out student, right? No, generally based on the existed example, this is already existed example only, right? From that student, here the possible number of geometrical isomers here 3 student here, and the possible number of geometrical isomers student here 6 student, right? Now the total number of geometrical isomers 9 here, right? Now look at student here. So there is no plane of symmetry here. Plane of symmetry is absent student. Here also plane of symmetry is absent. 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 Here also plane of symmetry is absent, right? Now if the plane of symmetry is absent student, I will get each structure by mirror image. So now I will get student optical isomer. This is 1, 2, 3, 4, 5, 6 student, right? The total number of optical isomers I can write student 6 into 2, because we will get its mirror image, right? The total number of optical isomers is equal to student 6, but usually we will consider only enantiomeric pairs only, right? Now I will write the final answer student. Generally the total number of geometrical isomers is equal to number of geometrical isomers is equal to student 6 student, right? Now optical isomers, right? Optical isomers is equal to student total number of geometrical isomers is equal to 9 student. So because 3 plus 6 is 9 only, okay, right? Total number of optical isomers is equal to student 6 into 2, that is equal to 12 student. But usually we will take student enantiomeric pair only, because one geometrical isomer already again repeating, so that's why enantiomeric pair is equal to, I hope my point is very clear student. Enantiomeric pairs is equal to student, I will write 6 only, right? Now tell me student, right? Maybe possible task from this example, how many optically inactive, right? So optically inactive isomers student, I can write 3. Optically inactive isomers student, I can write is equal to 3 student, right? Now the total number of stereo isomers is equal to total number of stereo isomers student, answer is 15 student, right? So this is execution the given example, right? Now maybe student you can execute it the given compound. Sir, can we write A to B? Yes, you can write student, right? We will observe the possibilities, we will check student, right? Now if I write this is A to B, this is one A to B trans, and one more student I can write A to C trans, and here I can write student A2D trans, and one more combination I can write student, just you can check it student, right? Now you check it, this is A2E trans student, right? The remaining you can arrange student, that is AC and DE, okay now, right? So this is AB and DE, okay now this is AB and CE, okay now this is student, this is AB and CD, right? Now we will write this combination student, you will get the idea, right? Now look at student, this I can write AB, AE, CD, and one more combination you can check it student, AC, AE, BD, and one more combination, this is AD, AE, BC, and this combination student AE, AD, BC. Now look at student, these combinations in above are repeated or not, once we will check it student, right? Now look at student, any combination is repeated, we will check student, right? Now any combination is repeated, we will check, right? Now from this student we have AB, we have AA, BC, right? Now you check here only student, right? So we have combination AE, BC, AD, AE, BC, AD, AE, BC, AD, AE, BC, AD. Now look at student, this combination is repeated. Now this combination is repeated, and here also you can check it student, AD, BC, AE, this combination also repeated, right? Next, one more combination you can check it student, AB, AE, CD, AB, AE, CD, AB, AE, CD, AB, AE, CD, right? Now look at student, this is AE student, right? AB, AE, CD, right? Now this combination also repeated. Now one more combination student, AC, AE, BD, AC, AE, BD, AC, AE, BD, AC, AE, BD, AC, AE, BD. Now look at student, this combination also repeated. So that's why if I write A2B, A2C, A2D, A2E trans student, these combinations are repeated. That's why we can cancel this student. So that's why for this particular example, the maximum number of possible geometrical isomers are 9 and the possible number of optical isomers are 12. That means if anyone asked enantiomeric pairs means, you can say answer is 6 only. Then the possible number of total stereo isomers is equal to 15 student, right? That's it, right? So just pause the video and you can watch student, right? So please like the channel student, right? Thank you very much. Right. So students, we will continue the possible number of geometrical isomers and optical isomers in a given complex MA₂B₂ CD. Okay, right. So first we will write the possible combination student. I will keep A to A trans student. So this is I will keep A to A trans, right. So now look at student, I will keep BB and CD. Already we know very well student, if any three ligands are same in a three ligands are present in a square student, the possible number of geometrical isomers we can write 2 student, right. So one more combination here I am writing student, just please observe. So this is A to A and one more combination, that is here I am writing, so B to B and C to D. This is the possible combination. Now here the possible number of geometrical isomers for A to A trans we are writing student 2. Okay. Now look at student, if the same ligands are trans to each other, generally the plane of symmetry is present student. Plane of symmetry is present student. So these two are optically inactive. My point is very clear. It is optically inactive. Now look at student, combinations here I am writing student, that combination AA, BD and BC, and one more combination student, you can check it, AA, BB, CD. This is the combination. Now the next following combinations I can write student, just you can write B2B, B2B, B2C, B2D, C2D combination I will write student. Then after we will cross verify how many combinations are repeated, right, we will check, right. Now look at student. So combination. So this is here I am writing student B2B trans, and one more combination here I am writing student. Combinations here I am writing. Combinations here I am writing, right. Now look at student. Now look at. So this is B2B combination, B2C combination, then B2D combination and C2D combination. So B2B combination, the remaining ligands we can arrange student AACD, right, AABD. Next remaining combinations we will write student AABC and AABB, right. So these are the combination, right. Okay, now look at student. So here B2B, right, the same ligands are opposite student. So generally plane of symmetry is present, it is optically inactive, right. Now combination here I am writing student. Combination is BB AD AC. Okay, now this combination student you can check it AD AB BC, right. So here no plane of symmetry student, anywhere no plane of symmetry here. So plane of symmetry is absent. Now look at student. So here combination here I am writing AC AB AB and BD, and here student this is, if I keep the plane student mirror image, then this will be cancelled to each other. Here plane of symmetry is present. Now the combination here I am writing student. Combinations are AB ABCD, right. Now so the possible combination student, the possible combinations are 1 2 3 4 5 6 student, right. Now the possible number of geometrical isomers student is equal to 6. Number of possible geometrical isomers is equal to 6 student, right. Now look at student, here also plane of symmetry is absent, right. Now the plane of symmetry is absent student. Optical isomers is equal to, I can write student. So the with respect to this mirror image possible, with respect to this mirror image possible. Now I can write student optical isomers is equal to, I can write student 2 into 2, that is equal to 4 student. So if you want to write enantiomeric pairs student, so enantiomeric pairs I will write the answer will be 2 only student, right. Now tell me student, the total number of stereo isomers is equal to, I can write student 6 plus 2, that is equal to 8 student. Now for example, if you have one more doubt also, sir, if any other possible combination, just you can write student the possible combination. You can write A2B combination, you can write A2C combination, you can write A2D combination, you can write, and cross verify, right. Now here I am writing student few combination, that is combination number 1. So that is A2B combination here I am writing, and one more combination here I am writing student, that is A2C combination, and one more combination here I am writing student, that will be A2D combination, right. The remaining ligand I can arrange student, that is ABCD and ABBD, and I can arrange this will be ABCBC, I will arrange. Now just you can check the combination student. So this combination is MAB AD BC, clear, right. Now this combination student AC BB BB AD, and one more combination student you can check it AD BB and AC. Check one student, if any combinations are repeated you can cross verify student, right. Now AB AD BC anywhere is there student, you can check it AB AD BC. Now look at student, here combination is present. Now I can cancel this, right. Now any other combination is there student, you can check it AC BB AD, AC BB AD. Now look at student, this combination also present. Now one more combination student AD BB AC, this combination also repeated only, right. So therefore student, you can write the possible combination, but the combinations are repeated or not, you can cross verify, then you will get the perfect idea, okay na, right. So please like the channel student, right. Next we will continue the one more example student, right? Next I will take one more example, that is MA₄B₂, right? So MA₄B₂ student, right? Now the possible combinations I will write student. Now I will take one thing student, b₂b₄ because all four ligands are same only, right? Now look at student, I will take b₂b opposite only. Now I will arrange this is A to cis only, A to A cis, A to A cis, and right now. So look at student. So the possibilities we can write only this one only, right? Now M4B2 complex student, we can write this is the cis isomer and this is student trans isomer. Cis isomer and trans isomer. Look at student, you can take any plane student. So plane of symmetry is, because this is B2B trans student, it is optically inactive only. It is optically inactive only. So you can take any combination student. For example, you can take this plane student, right? Now you can take this plane student, right? Now A to A and B to B are mirror images to each other. Here also optically inactive. So here also optically inactive. So student, the possible number of geometrical isomers is equal to, I can write student 2 only, right? So any optical isomers are there student? No student. Then total number of stereo isomers is equal to, I can write answer is student 2 only, right? M student, we can take anything student, right? Oxidation number, no issue. Metal atom, you can take anything student, right? Now we will move to the one more. Right. Next example student, MA₄BC. MA₄BC student, so we can write the possible combinations, right? Now look at student, I will write this A to A trans. Now I will write, so I will keep B2B, B2C cis, and I will keep B2C trans simple student. I will keep B2C cis and B2C trans, right? Now remaining ligands I can arrange. Now look at student, A, right? Now look at student. So B2C student, here everything is, this is a cis isomer, and B2C trans, it is a trans isomer. Now from this student, any plane of symmetry is present, we will cross verify. Now look at student, so the similar ligands are opposite to each other, trans to each other. Obviously this A to E trans student, then automatically it is optically inactive, that means pos is present. Okay, now similarly student, so if I use the mirror here student, so then it is also mirror image to each other, so here also pos is present, right? Now so here student, the possible number of geometrical isomer, so here student only 2. The possible number of geometrical isomers is equal to 2. Okay, right? So now tell me student, the possible number of optical isomers is equal to 0. Then the total number of stereo isomers is equal to student, answer will be 2, right? Now we will move to the one more example student, right? Now I will take one more combination, that is MA₃B₃. So this is most important example student. So now look at here, A and B are monodentate ligand only, right? Now look at student, so here you can write this combination student. These combinations here I will write in a 2 different way. The possible combinations here I am writing student. Now look at, right? Now look at, I will write this A here, and this is A, and this is B, right? So A to B, everything is trans to each other. Now look at student, one more combination I will write student. So this is, I will write A to A cis, right? Now look at here, this is cis. Now this is combination I will write student, so that is B2B trans, right? Now look at student, so here these are the 2 types of combination. Now look at student, so this is one this is one type of. Now look at student, so this is called as a facial isomer, right? Now how you can say this is a facial isomer student? It's a simple student. Now look at here, so if you can write student, the 2 ligands are in the plane square, and this ligand is look at the face of the A ligand, looking the face of the ligand. So that's why student here we are calling it is a facial isomer. Facial isomer. And look at student, the three ligands are aligned in the same plane. Now look at student, this is one, and look at student, so this is student, right? Now look at student, this is called mer isomer, right? Now, so one will be facial and one will be meridional isomer, right? Now this facial and meridional isomer, student, like that it is a cis isomer and trans isomer only, right? Now for this particular case, student, the possible number of geometrical isomer, student, only two only, right? So there is no possible optical isomer, student, only geometrical isomers are possible, and optical isomers is equal to 0, student. Then total number of stereo isomers is equal to 2, student. Right? Now we will move to the one more example, student. I will take one more example, that is M, A, B, C, D, E, F, right? These particular complex, student, how many possible isomers are there? We will check, student. Now look at, student, I will keep A₂B is trans, student. I will keep A₂B trans, student. The remaining I can arrange, student. This will be CD and I can arrange EF, right? Already we know very well, student, right? If four different ligands are present in a square, student, the possible number of geometrical isomers is equal to, I can write 3, student. Right? Now, so here we have 3 geometrical isomers, student. Right? Now, next student, look at, student. The remaining combination I will write, student, for this particular complex, right? Now you can write the combination, student. You can write the A₂B, already we finished, student. Now you can write C₂D and you can write C₂E and C₂F, student. And one more combination you can write, student. So D₂E and D₂F you can write, student. Right. Now the combinations here I am writing, student. That combination is a C₂D. And one more combination you can check it, student. One more combination, that is C₂D, C₂E, and one more combination here I can write, student. That will be C₂F. That will be C₂F, right? And one more combination you can check, student. Right. Few more combinations here I am writing, student. These combinations are you can write, student. That combination is C2D2E, D2E, and one more combination I can write, student. One more combination I can write, student, D2F. One more combination here I am writing, student, D2F, right? One more combination here I am writing D2F, right? Now look at, student, we will arrange all these ligands, student. All these ligands we can arrange, student. Now look at C2D means I can arrange, student. I will fix the AB position, student. I will fix the AB position, student. I will fix the AB position. I will fix the AB position. I will fix the AB position. You can check, student. I will fix the AB position. AB position, right? Now if I fix the AB position, then I can write, student, AB CD is there. I can write, student, EF, and AB CE is there, student. I can write DF, right? AB CF is there, student. I can write DE, right? Now AB DE is there, student. I can write CF, and look at, student, AB DF is there, student. I can write this will be CE, right? Now, so interchanging of these two, student, we will get, student, into 2. So we will get the 2 different. Interchange, student, we will get 2. Interchange, student, we will get 2. Interchange, student, we will get 2. Interchange we will get, student, 2, right? Okay. So now look at, student. So we will get, student, the total number of possibility here, student, right? So this will be C2D, C2E, C2D, C2E, and C2F, and D2E and D2F. Now look at, student. So one more combination also we can write, student. That combination is, student. So that combination is E2F. That combination is E2F. So E2F combination, I will keep the AB is cis. Then the remaining, student, I can write D, E to F means I can write C to D, right? Now, so here also student we will write 2, right? Now, the possible number of, from here interchanging we will get one more configuration, right? Now interchange we will get one more combination. Interchange we will get one more combination. Interchange we will get one more combination, because here I am keeping A to B fixed, 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 A to B fixed. Interchange I will get student one more combination. Now from these student, the possible number of geometrical isomers is equal to student 6 into 2, that is equal to student 12 geometrical isomer, right? So therefore student, the total number of geometrical isomers is equal to, total number of geometrical isomers is equal to 15 student, right? Every isomer is student plane of symmetry is option student. So therefore student, we will get the total number of optical isomers is equal to, total number of optical isomers is equal to 15 into 2 student, because we will get the mirror image. So that is equal to 30 student, right? Now, so enantiomeric pairs student, enantiomeric pairs I will write student, enantiomeric pairs is equal to student, I can write this is 15 only, because 15 pairs are possible, right? Now student, the total number of stereoisomers is equal to student, total number of stereoisomers student, that is equal to student 15 plus 15, that is equal to 30, right? Now tell me student, number of optically inactive isomers is equal to student 0. Optically inactive isomers is equal to 0 student, right? Every isomer, every combination has absence of plane of symmetry. That's why it will exhibit student optically active only, right? Now this is very important student, right? In exam no need to write all these combinations student, just we are writing the possible combination. Just remember the number student, because examiner is asking how many possible isomers are possible, how many geometrical, how many optical, like this type of questions are asking, right? Now look at student, we will move to the bidentate system case student, right? Now we will move to the bidentate ligand case. Bidentate ligands in coordination number 6 we will discuss student. Now look at student. Now look at here, I am taking the combination student MAA taken thrice student to the power of plus or minus student. M you can take anything student. N is the oxidation number student, right? Now tell me student, AE means nothing but student, it is a symmetrical bidentate ligand student, right? Clear student? It is a symmetrical bidentate ligand. It is a symmetrical bidentate ligand. So it is a symmetrical bidentate ligand. It is a symmetrical bidentate ligand. So can you write the example for symmetrical bidentate ligand student? So the beautiful example is student, so I can write CH2 NH2, right? Now this is ethylene diamine student. So this is ethylene diamine. This is ethylene diamine. Ethylene diamine. So simply we can label as student En. And I can also write student one more symmetrical bidentate ligand student. So this will be O minus, and this is C double bond O minus student, right? Now this is student oxalato. So oxalato also student, it is a symmetrical bidentate ligand, right? Now, so we will discuss the example student, right? Now I will write the combination student. For example, the examiner is given as like this student, Cr En whole thrice to the power of plus or minus n. You can take n will be plus 2 or whatever it is student, n will be plus 3, just you can go through, right? N will be does not affect to the geometrical isomer, optical isomer. Now look at student. Now look at here, this is the metal atom, right? So chromium is the metal atom student, right? Now here look at student, in bidentate ligand case student, trans is not possible student, only cis combination only possible, because it is a bidentate ligand means ring will be present, so that's why ring strain will be possible student. That's why in this particular bidentate symmetrical or unsymmetrical case student, you can write only cis position only. Now look at student, so this here I am writing 6 position student, 1 2 3 4, right? Now look at student, now this is N, this is N, this is N, this is N, this is N student. Now look at student, you can take this is one combination, this is next combination, this is next combination. Now look at student. Generally, most of the cases, sir, if it is a symmetrical bidentate ligand, right? So then what will happen, sir? Right. So I cannot write student transposition students is only possible, right? Now look at student. So sir, if I cut the mirror plane, right? So if you cut the mirror plane, you can take any imaginary plane student. Why? Because if you look at a plane student, right? Now if you look at a plane student, right? So one will be top student, one will be down. So this is top student, you can write student, this is the top, you can write this is bottom student, right? For example, now here I am writing this is N student, right? Now for example, this is look at here, right? Now so one top will be connected to this student, right? Now one bottom will be connected to this student. Now if you take any mirror plane student, if you take any imaginary plane, if you take any imaginary plane, if you take any imaginary plane, you can take any imaginary plane, you can take any molecular plane student, right? This molecule never goes under mirror image student. That's why if any COEN taken thrice is given student, symmetrical bidentate ligand is given student, trans is not possible student, cis case 100% you can say answer student, it is exhibit optically active, right? Now student, we will get its mirror image student, right? Now look at student, see here I am writing its mirror image student, here I am writing its mirror image, right? Now look at student, here I am writing its mirror image. Now this is the mirror image I am writing student. Now here I am writing the mirror image. Now look at student, trans is not possible student, trans is not possible. Now I am writing its mirror image. Now this is chromium, right? Now I will write this is N, right? Now this is will be N, this will be N, this will be N, this will be N, right? Now look at student, right? Now I can say this will be a D isomer and this will be a L isomer according to this, right? Okay, right? Now you can argue question, sir, if I like this, no issue, right? We will get the one will be the mirror image only, right? Now here, so therefore student, right? Now the possible number of isomers student, right? How many geometrical isomers are possible student? Only one geometrical isomers are possible, right? Now how many optical isomers are possible student? 2, right? Now but how many pairs are present student? Only one enantiomeric pair is present. Only one enantiomeric pair is present student, right? Now tell me answer student, the total number of stereoisomers is equal to student, the total number of stereoisomers is equal to student, answer is what? 2 only. This is regular example student, most of the questions examiner asking these 2 student, right? Just you can concentrate here, right? Okay na? Right, no plane of symmetry student, right? Next we will move to the combinations of this symmetrical bidentate ligand student. I will take one more example student, right? Now here I am taking M, here I am taking student AA twice and here I am taking B2. This is one more combination student. Now here you can take same student, you can take CrEn twice Cl2 to the power of plus or minus n, right? Now I will write student combination, I will write the combination student, just you can check the combination, right? Now one more combination I will write student, right? Now look at student, these combination student, here I am keeping this Cl cis to each other and I can write student this Cl trans to each other, right? Now I can orientate the remaining ligand, so this will be N, this will be N, this will be N student. Now this is one ligand and this is one ligand. Now I can say student, this is the cis isomer. Now these are trans to each other student. Now this is a trans isomer. 2 Cls are trans to each other student. Now this is the trans isomer. Now this is student, right? Now this is right. Now look at student. Now look at student. So if the similar ligands are opposite to each other, trans to each other student, right? Obviously plane of symmetry is present student, right? Trans case, right? Trans if two bidentate ligands are present and two monodentate ligands are present, student, cis only optical active, student. Trans case plane of symmetry is present, student. Say answer, it is what, student? Optically inactive. It is 100%, it is, student, optically inactive. Right. Now look at, student. Right. Now look at, student. So this will get, student, one mirror image, student. I will write the combination. This mirror image combination I will write, student. I will copy this diagram here, student. Now this is the diagram here I am copying, student. Right. Now I am pasting. Right. Now I will take its mirror image, student. Now I am taking its mirror image, student. Just you can check, student. This is the chromium. This is the chromium is our central metal. And now look at, student, here I am taking its mirror image. Now here I am taking its mirror image. Right. Now this is N, this is N, this is N, this is N. Now look at, student, this will be mirror image to each other, student. These are mirror images to each other. Right. Now tell me, student, how many possible isomers are there, student? Right. Cis is present, trans is present, two geometrical isomers present, that is 100% accepted. Now, so now look at, student, the number of geometrical isomers I can write, student, number of GI is equal to, I can write, student, 2. Right. Now I can write, student, number of optical isomers is equal to, student, I can write to 2 only, because of this is I am getting the mirror image. Right. Now I can write, student, number of enantiomeric pairs is equal to, student, I can write, student, only one only, because I am getting only one pair, because this is already cis is repeated. Right. Now, student, the total number of stereoisomers is equal, I can write, student, answer is 3 only. Right. This is the most important example, student. Just you can revise the example and practice, student. Now I will take one more combination, student. That combination here I am taking same example, student. CR EN twice. Now here I am changing, student. In place of one more CL I can change with BR, student. Right. Now here also I can write, student, possible combination. Right. Now I will take this B bromine and okay, you can take chlorine and bromine, student. I will keep cis position. Right. Now this bromine and chlorine, student, I will keep transposition. Right. Now I will, because I cannot write this bidentate ligand in a transposition, that is not possible. Now this is the one combination, student. Right. Now I can write, student, this is N, this is N, student. Right. Now this combination I can write. Now I hope it is very clear. Right. Now look at, student. Now look at. So this is, student. Right. This is, student. If I take this particular compound here. So this is, student, mirror images to each other. In this particular case also, student, trans is optically inactive. Trans case, student, optically inactive. Trans case, student, optically inactive. Trans case optically inactive. Right. Now look at, student. Now look at. So now this is the cis case, student. Right. Now I can write this cis will be what, student? Right. So mirror image, right. Now listen, student, if bidentate ligand, student, with 3 bidentate ligands are present, student, say answer 100%, cis is the optically active. In bidentate ligand, 2 bidentate ligands are present, student, cis case 100%, it is a optically active. Now look at, student, here I am writing its mirror image. Now here I am writing, student, its mirror image. Right. Now this is chromium. Right. Now here I am writing, student, this is N, this is N, this will be Cl, this will be Br. Now this is N, student. Right. Now this is, student, N. Right. Now here mirror image is possible. Right. Now cis isomer is optically active. Cis isomer is optically active. Cis isomer is optically active. Right. Now cis isomer is optically active. Very good. Now tell me answer, student. Number of geometrical isomers is equal. Answer will be, student, 2 only. Why? Because one cis and one trans only. Right. Now number of optical isomers is equal to, student, I can say answer will be 2 only. But number of enantiomeric pairs, student, I will write answer is equal to, student, number of enantiomeric pairs I can write answer will be 1 only. Now tell me, student, total number of stereoisomers is equal to, student, answer is 3 is the right answer, right? Now this is one combination. Now I will change the combination, student. Now I will take example MAA, I will change, student, A2, B2, C2, right? Now you can take, student, C2, D2 or anything you can take, student. So one only bidentate ligand, the remaining 4 ligands are, student, monodentate ligand, right? Now I will write the combination, student. Combinations are not very tough, student. Just you can keep the A to A trans only, A to A cis only. Now I will keep, student, A to A cis, right? Now I will write, student. So one combination I will write, student, B2C trans, and one more combination I will write, student, B2B cis, and one more combination I will write, student, so C2C trans, right? A B2B trans, C2C trans. Clear, student? Right. Now, so from this, student, this A to A position is fixed, student. A to A position is fixed, student. This is cis only possible. Now A to A position is fixed. Now remaining ligand you can arrange, student. I will arrange B2B, C2C, right? Now I can arrange, student, CC, right? Now I can arrange, student, this will be BB, right? Now look at, student, from this, student, so plane of symmetry is present, student. Here also plane of symmetry is present, because so now if you take the mirror image, student, right? If you take the mirror image, student, so if you take the mirror image, student, right? Now these are, or you can take, student, simple only, right? Now no need to take this mirror image, student. No need to take this mirror image, student. Simple, you can take, student. Similar ligands are opposite to each other. Similar ligands are opposite to each other. So then 100% it is optically inactive, only plane of symmetry is present. Now this particular case, student, there is no plane of symmetry right now, student. So plane of symmetry is absent. So that's why here you will get, student, one mirror images to each other. So then you can, student, now you can ask, sir, if I am changing interconversion, is there any changes, student? Right now look at, student, B2B 90 degrees only, C2D 90 degrees only. If I am changing the angle, then what will happen, student? Now same, right? So B2C 90 degrees only, right? Here also B2C 90 degrees only. So by changing the angle, there is no change in any orientation, student. So because symmetrical ligands are present, student, because these two ligands are symmetrical only, by changing there is no change in the bond angle, student. So that's why we cannot get one more possible, student. Now therefore, student, the number of geometrical isomers is equal to, student, I can write 3, student. Number of geometrical isomers I can write, student, 3 only, right? Now look at, student, from this I am getting the mirror images, student, right? Now optical isomers, student, I can write 1 into 2 only. Accept or not, student, right? Now number of optically inactive, student, I can write optically inactive isomer, student. Optically inactive isomer, student, 2, right? Now how many stereo isomers are present, student? Right? Now here I will take only one enantiomeric pair. Now this is enantiomeric pair, student. Enantiomeric pair. Now this enantiomeric pair is equal to only one, student, right? Now, student, number of geometrical isomers 3 and one enantiomeric pair. The total answer will be, student, 4, right? So now this is example of MAA₄B₂C₂, right? Now follow the lecture, student, right? Now look at, student, right? So now if you see the any other YouTube video, student, maximum here I am giving the better clarity, student. Just pause the video and copy the notes, and you will get the exact what possibilities we are writing. Now next, student, here I am taking one more combination, student, MAA BCDE, MAA BCDE, right? From this case, student, how many possible we will check, right? A combination you can write, student. A to A you can keep always is only. Now you can write, student, one combination I can write B2C, accepted or not. One combination I can write B2D trans, and one combination I can write, student, B2E trans, right? One more combination I can write, student, C2D trans, and another combination I can write C2E trans, and one more combination I can write, student, C2E cis only, D2E cis only, right? Now these combinations here I am writing. Then we will check one by one, student, right? Now A to A I will fix, student, right? Now first combination here I am taking, student, B2C. Now look at, student, Here one combination will be B2D and one more combination you can check student B2A. Am I correct or not student? Now look at student A to A. If I fixed A to A combination here I am fixing. Now look at student. The remaining you can write student. So BC is there. You can write student DE. Okay. So BD is there student. You can write CE. B is there student. You can write CD. Right. Now look at student. From this right, by interchanging of these two student, anything is possible. You can cross verify student, interchanging of these two student, because here we have symmetrical ligand, right? If you interchange, there is no change in the bond angle, right? So that's why student we cannot get any other possible geometrical isomer, right? If we cross verify student, right, A to D cis only, A to C, A to E cis only. Now if I am changing student, E will comes here, D will comes here, again A to E angle will be 90 and A to D angle will be 90 only. There is no change in the bond angle student. So that's why I cannot write any other possible geometrical isomers here, right? Now we will move to the remaining other combination student, right? Now look at student, the remaining other possible combination here I am writing, right? Now so B combinations are over student. Now I will write C2D combination, right? Now I will write student C2E combination, and one more combination student I will write D2E combination. I hope my point is very clear, right? Now this A to A will be cis, A to A will be cis student, A to A will be cis student, right? Now so just you can check it student, just you can check it. A to A C to D is over student. Then I can write the combinations are, I can write the combinations are BE, right? CE will be there student, I can write BD, right? DE will be there student, I can write BE, BC, okay, right? Right. Now here also interchanging of these, you cannot get anything. You cannot get anything by interchanging of these two. Interchanging of these two, you cannot change in bond angle. So that's why there is no other possibility of geometrical isomer. Right? Clear? Right. Now look at student. Now the total geometrical isomer student 1, 2, 3, 4, 5, 6. Right? So now total number of geometrical isomer student 6. Right? Now look at student. Any plane of symmetry is present student. Now you can check it student, right? Everything will be trans to each other only. There is no symmetrical, right? So that's why here plane of symmetry is absent. Here all the cases pass is absent. All the cases pass absent, right? And now you can check it student. You can take any imaginary plane, just you can check it. You can take any imaginary plane, you can check it, right? So all the cases plane of symmetry is missing student. So that's why I can write student each and every case I can write into 2, right? Because I will get the mirror image student 1 into 2, 1 into 2, 1 into 2, right? So that's why student I can write 6 into 2 is equal to 12 student, right? Now enantiomeric pairs student, enantiomeric pairs student, enantiomeric pairs student, that is equal to student, I will write answer will be 6 only. Am I correct or not student? Right. Now tell me student, total number of stereoisomers is equal to student 12. Most important question student, just you can practice the example, right? I hope, I think you are following, okay? Right. Now next I will take student one more example, just you can check it student. One more example student, here I am taking, right, one more example here I am taking MAA and B2CD, MAA B2CD. Now in this case also you can check student, right? Possibilities you can write student, right? Now I will write one B2B and I can write one will be C2D, B2C, B2D also I can write, but we will cross verify. Okay, now I will write student, one will be one combination I can write student. So this will be B2B I am writing student, right? One more combination I can write student, B2C, and one more combination I can write student, so B2D, and one more combination I can write student, C2D. These are the possible combination. Okay, now, right. Now I will arrange this A to A cis only. I will arrange this A to A cis only. I will arrange this A to A cis only. I will arrange this A to A cis only. I hope my point is very, very clear. Okay, right. Now this I will arrange CD. Okay, now. So this is BC student. I can write VD. Okay, now. So BD will be present. I can write BC. Right, AACD will be there. I can write it BB. Okay, now. Right. Now look at student. Now look at student. So B to B student, plane of symmetry is present because same ligands are trans to each other. Plane of symmetry is present. Okay, now. Right. Now look at student. Now look at. So any other possibility you can check student, right? Now here also you can take the mirror image student. So these similar ligands are present. Here also plane of symmetry is present. Okay. Now, so now you can take any imaginary plane student. So this pos is absent student. Here also pos is absent. Pos is absent right now. So from this I can write 2 mirror image. 2, 1 into 2, 1 into 2 right now. So now look at student, right? By interchanging this, anything you will get, you cannot get anything student because we have a symmetrical bidentate ligand. By interchanging, there is no change in the bond angle. So please remember this particular point. Okay, now, right? Now student, I can write the total number of geometrical isomers is equal to 4. Okay, right? Now, how many optical isomers are present student? Optical isomers is equal to this optical isomers is equal to student. Here plane of symmetry is present. Here plane of symmetry is present. Here only right now optical isomers is equal to, I can write 2 into 2, that is equal to 4. Okay, now, right? Enantiomeric pairs is equal to answer is 2 only, right? Now total number of stereoisomers is equal to answer, I can write student 6 only because 4 plus 2 only, right? Now this is example case of student MA₂B₂CD, right? Now we will move to the one more example student. Just look at student. Now I can write student combination MA₂B₃C, right? Now this combination student, you can write the possible combination, right? Now I cannot write bidentate ligand in transposition. Now I will write one will be B to B and one more possibility I have B2C, right? There is no more further combination. I can write these possible combination only, right? Okay, now look at student. Now if B to B, then I can arrange remaining will be BC. I can arrange this will be B to B, right? Now here, so pos is present student. Here also, right, ligands are up trans to each other. Pos is present now. So therefore student, number of geometrical isomers is equal to 2 only. Okay, now so any optical isomer student 0. Optical isomers is equal to 0 because nothing is right. So here plane of symmetry present. So that's why. Now tell me student, total number of stereoisomers is equal to 2 only. Okay, now, right? So please check it student. So these are the possible orientations of related to what student? M. Now we will move to the another system student. We will go to the MA₃B taken thrice system. Okay, right. So in this system student, AB is a unsymmetrical bidentate ligand. AB is unsymmetrical bidentate ligand. Unsymmetrical bidentate ligand. Unsymmetrical bidentate ligand. Okay, now unsymmetrical bidentate ligand students, we have example is NH2 C double bond O minus. So now this is glycine A2 student. It is a bidentate ligand. 2 donor atoms, one will be nitrogen side and one will be oxygen side. Now, so this particular student, here we will write the example of CrEn whole thrice to the power of plus 2. Okay, right. Now in this case student, it is look like a MA₃B₃ system only. Right now, it is like a MA₃B₃ system, like a A3B3 system. Okay, now we will write the possible combination, student, here. So this is chromium. Now this is A, B, A, B, A, B. Now this is one combination, this is another combination, and this is one more combination. Okay, right. So now look at, student. So we will do the small changes, right? First of all, so now how to get the combination, student, right? So just you can write the possibilities. If I am writing combination, opposites I am writing, look at, student. So one combination will be BB. Here BB I am writing, and one will be AB and AA combination. Opposite only I am writing. Now I will do interchanging of these two. Now here I am doing the interchanging. BA here I will write. Now you can observe, student, what is happening here. Just you can get the idea. Okay, so don't by heart, just follow the process, right? Now here I am changing. So BA. Now I will keep all these are. I will keep all these are. Right. Now look at, student. Now I am not changing anything here. Just I am changing it. Now just check the combinations. Now just check the combination right now. So one combination is AB, BB and AA. Now compare to, look at, student, here the combination is MBB, AB and AA. Check it, student. AB, BB, AA. So by interchanging this, there is no change, right? Now I can eliminate. Now I will do one more, right? Now if I change like this, student. Now if I change like this. Now here I am changing like this. BA. Now I will keep this is as it is, student. Here I am not changing anything here, right? Now I will keep like this, right? Now here I am changing, right? Now look at, student. Check the combination. Now here I am getting the combination AB, AA and BB and BB. So here also there is no change in combination by interchanging of these two. Interchanging of these two, here I am not getting. Now I will do one more interchanging here. Now we are trying to get the possible answer, right? Don't by heart, right? Just possibilities we are writing. Now I will keep this is as it is, student. I will keep as it is. Now I will change this combination B, A, right? Now this becomes, student, A, B. Now here. Now look at the combination, student. Now this is M, AB, 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 AB and AB. Now look at, student. The combinations are repeated? No. So this is different and this is different. So now look at, student. Here, so this is optically active. Here it is optically active because of ligands are above the plane, below the plane are present. So bisecting the imaginary plane never will be get the mirror images, right? Now, so therefore, student, you will get this is 1 and this is 1, student, right? So now look at, student, right? So now here number of GI is equal to, student, 2, right? Then number of optical isomers is equal to 4. Number of optical isomers is equal to 4. Right. Now number of stereo isomers is equal to, student, answer will be 4. Right. So this is about, student, M, A, B taken thrice. Most important, student. So advanced point of view, mains point of view, this question is very, very important. Possibilities, everything I mentioned, student. Just don't by heart, just practice the example, that's it. Now we will move to the one more segment, student. One more example, just check it. Now I will change the combination M, AB twice and B2. Okay. Or else you can take, student, or you can take same chromium example here I am taking. Now here I will take AB twice and Cl2 I will take. So to the power of plus or minus n. Now look at, student. Write the combination. Now this is Cl and this is Cl. I will keep AB like this. I will keep AB like this. Now look at student, I will write both CLs are on like this student. So Cl I will write student. Now this will be AB. Now I will write student AB. Right. So look at student, so these are opposite student. So plane of symmetry is present, right? So it is optically inactive. It is optically inactive. Now do one thing student, by interchanging of these two, anything you are getting, just we will cross verify here. Interchange student. So combination you can write student, combination here I am writing CL combination. Then next combination student, AB combination. AB combination. So by interchanging this student you are getting anything. I think student this will come BB. Oh right. So by doing interchanging I think we are getting the new thing. Now look at student. So this is BA and I will keep this is AB. I hope my point is very clear. Now look at. So this is CL student. Now here I am writing this student CR. CL is okay, right? And one will be AA and BB. Okay. So interchanging we are getting. So here also plane of symmetry is present student. So we optically inactive only. Okay na? Right. Now from this student, combination first I will write. Combination I can write ACL and BB. Okay na? Right. Now if I do interchanging student, if I am interchanging of these two, I think I will get ACL BB only seen. So here interchanging there is no use. Interchanging no use. Now we will do interchanging here. We are getting or not anything different. Now look at student. I will keep CL as it is. Right. Now here I am interchanging this. Now this will be BA and AB I will write. Now look at student. Now here combination, once you write student CR, combination will be ACL and BCL and AB. I think ACL BCL, right? Combination is differ. Now if you change this combination, for example, sir, why you are not trying here also? Now okay. So we will write here also. Once we will change the interchange. So what will happen student? We will check. We will get the clarity. So this will be CL. This will be student. Right now here what is the structure? This will be AB. Okay na? This will be AB. Now here I am interchanging. This will be BA. Okay. Right. Now you check the combination. So chromium. This will be BCL, ACL and AB, right? So no change, right? There is no use. By changing there is no use, right? Now from the student, the possibilities here we have 4. The possible geometrical isomers are 4 student. Possible geometrical isomers student. Once you check the possible geometrical isomers 1, 2, 3. Now you can do one more combination also student. Right now look at here. This I will keep CL as it is. Right now here I will keep this BA as it is. Now here I am doing interchanging here. Now I will write student this interchanging. This will be AB. This will be BA. This will be BA. Now once we will check any combination is differ or not. Combination AA, BCL, right. So this combination also showing differ. So from the student, this is 1, 2 and 3, 4, 5. So because this is already repeated. So now totally we are getting 5 geometrical isomers student. So number of geometrical isomers is equal to 5, right? Now this is plane of symmetry, this is plane of symmetry, this is optically inactive only. So this is optically inactive only. Now optically inactive only. So from the student 1, 2 and 3. So I hope we will get student Optical isomers is equal to student. We have 3 into 2 student, that is equal to 6. But enantiomeric pairs I will write as enantiomeric pairs, that is equal to 3 only student. So then the total number of stereoisomers is equal to 8. Clear student? Right. So just you can change the configuration. That's it student. Now look at student. One more example we will take student, that is MAB twice BC. MAB twice BC. Now look at them. Here also you can take CR also same. CR glycine twice and CLBR you can take, best example. So plus or minus L. Okay na? Right. Now look at it. So this first I will write the combination. Now I will write this combination BC. Now this is A B. One more combination I will write b₂c opposite. Now this is A B. Okay, so this will be, now you can check the combination student. M, this will be AB and BC. This is one combination. And one more combination student, just you can check it here. This will be AB and BC. This is one combination. Next we will do one thing student. By interchanging of these, we are getting anything differ, we will check student. So now I will interchange these two student. I will interchange these two. Once I will check, is there any possibility differ by each other, we will check student. Now look at. So now I will keep CR as it is. Now this is, I will change, this will be C and this will be B. Now I will keep, this will be AB and AB as it is. Now I will write the combination. So this will be AC, BB and AB. So AC, BB, AB. Okay, somehow differ. So this is also one possibility, right? Next, one more possibility we will write student. So trans here we will write as it is interchanging anything possible, we will check student. Interchanging anything possible, we will change here, interchanging. So this is interchanging here I am doing. So this will be B and here I will write this is BA and this I will keep AB as it is. Now this will be C. Now here combination here I am getting, this will be AA, BB, BC. So now this is also differ. AA, BB, okay, now this is also interchanging, also we are getting the different thing, right? Now good. Now any changes we will do here student. Now if I change here AB, I will do this interchange. Now if I do interchange here student, I will keep BC as it is, no change. So BC I will keep as it is. Now I will keep AB as it is. Now here I am changing this BA. Possibilities we are searching student. Now chromium combination I will write AB, combination I can write BB and combination AC. Now combination student, capital B is there, capital B is there, and AB, AC. This is also differ. Okay, right. Now next we will move to the different things student. Now this will be CR. Now once we will change this configuration, this will be we will keep as it is. Here also we will keep BC as it is. Bottom one we will change student. We will do correction here. we will do interchange. So I will keep AB as it is. I will keep AB as it is here. 1 second, student. Right, AB as it is. Now I will change, this will be BA. Now we will write the combination chromium AA, BC and BB. AA, BC, BB. AA, BC, BB. AA, BC, BB. AA, BC, BB. Here you check it, student. Capital B, small c, capital B, small c, capital B, small c, capital A here, but capital B is there. So I think here we are also getting here differ. Now here also we are getting differ, right? So now, student, the total number of possibilities here for AB twice BC, we are getting 1, 2, 3, right? 4, 5, 6. So we are getting 6. Now one more thing also we will do, student, here. So we will change these two, interchange. So previous example also we will change both, student. Now I will keep BC as it is. I will change these student, right? We will get an idea. So now here this will be BA. Check it once. This will be AB now. So I will write this will be BA. Okay, now I will check the combination. So these combinations are CR, AB, AC, BB. Once you check, student, anywhere this combination is repeated, AB, BB, AC. Okay, this combination is repeated. So now that's it, students. So the possible number of 1, 2, 3, 4, 5, 6, right? So number of geometrical isomers 6, student. Number of geometrical isomers 6. Number of geometrical isomers is equal to 6. Now look at, student, here this is plane of symmetry is present. So now here we will get one mirror image, student. So this is, we will get 1 into 2, and here we will get, this is 1 into 2, right? Now here also no plane of symmetry, here 1 into 2, so 1 into 2, so here I think 1 into 2, right? Now number of optical isomers, student, optical isomers is equal to 5 into 2, that is equal to 10. So then number of optically inactive, student, 1, optically inactive 1. Now number of stereo isomers is equal to 6 plus 5. Total answer is 11. Right. Now what we did, student, just simple combination we copied and one by one interchanging we did, right? So then possibilities we are getting where any pos is present, then optically inactive, that's it. There is no other, student. Right. Now we will move to the next segment, student. Now look at here, M. Now I will write combination is, student, M, AB, B₂, C₂ to the power of plus or minus. Now this combination, same combination, student, just we will try to write combinations, right? Now this is 1. Now I will do one thing, student. B₂B I will write trans, and I will do one more thing, C₂C trans, and I will do one more thing, student. So B₂B trans. B₂B trans means I will write B₂C trans. Now I will write AB is fixed. Now AB is fixed. Now AB is fixed, student. This is, I can write this will be CC, and now I can write this will be BB, and now I can write this will be BC, right? So from this, student, from this, how many possibilities are there, we will check. Now look at, student, so here this is opposite, so now plane of symmetry is present. Here also plane of symmetry is present, but here plane of symmetry is absent. Right? Now we will do one thing, student. By interconverting, by if you do interconversion, because these two are same only, there is no use. Now if I do interconversion, student, so now I will write the combination first, student. Combination AC, BC, BB combination. Okay. Now if I do interchanging, just I am writing here only, then I will get AC, BC only. So there is no use, student. By doing interchanging, there is no use here. Now here also you can change. Now you can do one change. Here you can write CB. Then what will happen? We will check, student. Now if I am doing interchanging here, what we are getting, we will check right. Now here I am doing interchanging here. Now this is AB. Now this is CB. And here, right. Now look at, student. So we are getting the combination. This is AC, BB and BC we are getting. Okay, by interchanging this, we are getting one more combination additional. Okay, now look at, student, this is a plane of symmetry is present, here plane of symmetry. So same thing, student, same thing. By interchanging here, there is no change. But once we will check, student, if we do interchanging here, anything we are getting, we will cross verify. So now look at, student, the combination is AB and BB and CC. By interchanging this, student, interchanging this will be BC. Now I will write the interchanging combination. This will be AB as it is, there is no issue. BB as it is, there is no issue. Because one will be this will be BC. This will be AB, okay, and this will be BC, and this will be BC. Now you check, student, AB, BC, AB, BC, BC, AB, BC, BC. Okay. By interchanging, we are getting different configuration. Interchanging, we are getting different configuration. Similarly, you can do, you will get the same thing only, student. Right? Now look at, student. Now if I am doing interchange, now look at, student, we are getting 1, 2 extra. Here we will check here, anything extra we are getting, we will check right now. Now if I am doing interchanging here, I think there is no change right. So interchanging we cannot get anything, student. So therefore the number of possible geometrical isomers, number of possible GIs is equal to, student, 5. Because from here we are getting, this will be one combination, student. This combination is AC capital, right. So here this is different, student. Once we will cross verify, student, any combination is repeated. Now this is MAB BB CC. Now once I will write this combination, student, I will write this combination AC BB and BC. This combination is repeated. Once we will check, student. If the combination is repeated, then automatically we will get the wrong answer. Now AC, BB, BC. Oh, here this combination is repeated. Now look at, student, the possible number of geometrical isomers here. The possible number of geometrical isomer for this particular example, student, 4 only, not 5, student. This is very, very important. Please look at the example. Right. Now look at, student, the possible number of geometrical isomers we got 4. Now number of optical isomers, student, number of optical isomers is equal to, here plane of symmetry is present, here plane of symmetry is present. I hope we are getting here, this will be only no plane of symmetry, we are getting only 2. We are getting 2. Any other we will check, student, any other we will check. By here plane of symmetry, I think here we are missing the plane of symmetry. By if I am doing interchanging here BC, interchanging here plane of symmetry is missing. So here we will get into 2, student, right. So this combination, I think we will get one more additional, student. So then the total number of possible optical isomers is equal to 2 into 2. So then number of stereoisomers is equal to, number of stereoisomers is equal to 6 is the right answer, student. Just you can cross verify, student. So if anything is little bit mistake is there, so please comment section, student. Just I will revise the example. Right now we will move to the last example. We will move to the one more example, student. That is MA₂B₂CD. Now the possible combination I will write, student. Now I will keep AB as it is, student. Now I will write B2B trans once, B2B trans. Now I will keep AB as it is only. Then I will do one more thing, student. I will keep B2C trans. Then I will keep AB as it is only. Then I will do BTD trans. Then I will keep AB as it is. Now this I can write C2D, student. Now 4 possibilities I mentioned. So this is one will be B2B, B2C, and then B2D and C2D, student. Now look at the remaining we can fill, student. So this will be CD and this will be BD and this will be BC. Now CD will be there, student. We will write BB. Now from this, student, interchanging is possible. You can check, student. Now interchanging is possible here. So interchanging is possible. Now you will get 2, student. Geometrical isomers 2 are possible, interchanging. And but pos is present. Now look at, student. Interchanging here AB is different. Interchanging 2 possible. Now good. So no pos, right? Student, here pos is absent. Now interchanging, student, interchanging here. So AB different, student, we will get into 2. Interchanging we will get, right. Now look at, student. So here interchanging, I think there is no use. Interchanging here there is no use because here we have similar ligand. Interchanging no use. Interchanging no use. Interchanging no use. No use. Interchanging no use. Right. Now look at, student. Here we have 2, 2, 2, right. Now number of geometrical isomers 7, student. Number of GI is equal to 7. Clear? Number of GI 7. Now if number of GI 7, then here only pos is missing. Now here pos is missing. Pos is missing. Here also pos is missing. Now here we will get 2, 2, 2, right. Now we can write. Now this will be straight. Interchange we will get one more. Interchange we will get one more. Interchange we will get here pos is absent. Interchange we will get, student. So now look at, student. Interchange we are getting 1, 2, 3. So now look at here. Interchanging here it is pos is present here. Now interchanging is not possible. Interchanging is not possible means 2, 2, 2, right. Now 7 only. Now pos is absent but interchanging is not possible. Means here we will write, here we will get 2 possible, right. 2 possible and here 2 means 4 plus 4, 8. 8 here only I think we will get, student. Only interchange is not possible but we will get the mirror image. So that means, student, I think you are following. Number of optical isomers is equal to 5 into 2, that is equal to 10. Why? Because this you will get one mirror image. Am I correct? Similarly, it interchange also you are getting one more mirror image. I think here we will get 4. I am very clear. Now here we will get one mirror image from here. Interchanging also you will get one more mirror. Total will be 2. Now here interchanging is not possible but you will get only 2 now. Now the number of possible optical isomers is equal to 10. Now number of stereo isomers is equal to, I can write, student. This will be 7 and this will be 5 only. Now total number will be 12 only, right. Now next we will move to the one more example, this case, student. Now I can keep this is A, B, C, D, E, F. Okay now. So simple, student. Now you can write combination. Now I will keep this combination AB as it is. Okay now. right? Now I will write one will be CD. Now I will write EF. Now I will keep AB fixed, student. I will keep AB fixed. Now look at, so CD I finished now. Then I will write CE CF. Now CE. Now here I will write CF. Now AB I am fixing. Now I can write DE. AB here I am fixing. Now I can write this will be DE. Now okay. So one more I will do, student. One more I will do. Now I will fix the AB as it is. Now DE over DF is okay. DF I will write. DF I will write. Now one more also I can write, student, EF also. Now this is EF. Now AB I will fix, student. AB I will fix. Now this will be CE means I can write DEF. Okay, now CF is present means I can write DE. Now DE means DE present means I can write CF. DF is present means I can write CE. Okay. Now EF is present means I can write CD. I hope clear. Now look at, student. I think there is no plane of symmetry, student. 1, 2, 3, 4, 5, 6, student. Each interchange I think we will get. Interchange is possible. Interchange is possible into 2. Interchange possible into 2. Interchange possible into 2. Interchange possible into 2. Interchange possible into 2. So we have 6 GI, student, but interchanging is possible. That's why here I am writing 6 into 2 is equal to 12. Now 12 geometrical isomers are possible. Now everywhere plane of symmetry is missing only. Now if plane of symmetry is missing, student, each case we will get 4. Am I correct? Each case we will get 4. 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 Now optical isomers is equal to, student, I can write 12 into 2, that is equal to, student, 24. Now so number of stereo isomers is equal to, student, I can write 12 plus 12, answer will be 24, right? So these are the possible geometrical isomers in the case of all these bisymmetrical, unsymmetrical bidentate ligand. Okay now, right? So just you can check, student. Maximum I covered all the example, right? So if anything I did mistake, students, so please comment on section. Again I will cross verify. Maximum I covered all the things, student. Just you can check. So please like the video, right? So it will be reached to more number of student. So I covered maximum advanced level questions only, advanced level example only, right? So thank you.